gonna show you the internal parts of a DC motor. I had a lot of motors. I found some sneaking here and there in my room. These are all brushed DC motors, and brushless DC motors are different. I did the teardown of some of these motors to represent you the internals. First, I want to show you how the coil creates magnetic field. So you can see it's a solenoid here. It's a multi-turn single coil winding, and you can see the winding is over a metal here. So this metal will turn into a magnet when we will supply current into this coil. So we'll see that in a bit. But this solenoid also can work as a resistor. I have used a lot of times this as a resistor. It actually drops the voltage because of this multi-turn winding here. So I will supply 5 volt to it, but it is very dangerous because it's a short circuit here. So if you supply a lot of power into this coil will heat up pretty quickly, so there is a possibility of burning this coil. So let's try it for a short period of time. Okay, so before connecting, I want to make sure that this is not magnet yet. So you can see it's iron shaft here. So you can see it's not magnet yet, it's just metal. So let's supply power to it. Okay, now the power is connected, and you can see it's attached now. You can see this coil is creating magnetic field. So now you know how coil can create magnetic field flux. So now I will disconnect the power. Yeah, you can see. Okay, so in the field circuit and in the armature where we will find windings, the magnetic field is generated by the same principle as a solenoid works as a magnet. So you can see some motors are here. These are all brushed DC motors. So now we will see the internals of these motors, but first this is the outer shell of this motor, and you can see these two are magnets, and these magnets are a replacement for a field circuit. I want to show you a field circuit here. You can see, suppose this is a metal ring. This can be also steel laminations. Sometimes this field circuit or field section is called the stator. So you can see it's delta type of winding, and it has 3 phase 1, 2 and 3. So this field circuit is a replacement of these two magnets. Here the field circuit is the magnets. So the magnets does what a field circuit does. So if you use, or if a motor uses magnets as a field circuit, then no need to use this type of field circuit. So the armature here, it goes inside the field section here like this. So when current will pass through these field coils, it will create magnetic field flux, and the armature will also create flux, so the armature will start moving. So now we know how field circuit works. Now we can bring this big large motor here so we can understand everything properly. So you can see this is the armature, and here you can see very thin steel plates. These steel plates are stacked on top of each other, creating steel lamination. So this armature has 1, 2, 3, 4 and 5, so total 5 poles. So this is a 5-pole armature, and this one has 3 poles, 1, 1, 2 and 3, so it's a 3-pole armature. You can verify this. So this one here, it's also 5-pole armature, 1, 2, 3, 4 and 5. Now we can see the commutator part. This part is the commutator. This commutator has also 5 plates, 1, 2, 3, 4 and 5, but you can see this commutator is almost destroyed because of overpowering it. So we can bring this guy here. It's also 5-pole armature. So you can see here the commutator mechanism. It has 5 plates. Those windings are connected here, 1, 2, 3, 4, 5. I actually did the winding of this armature, you can see. So if you want to redo the winding, you need to set a starting point in this connector here. Then you will start making turns. Then after finishing this pole, you will connect the coil here. Then you will finish this pole. Then the rest of them as I showed before. Now we will see the bottom part that holds the brushes. So this bottom part is for this big armature, but if you notice closely, you will see the brushes are destroyed completely. There was a brush in this terminal and also in this terminal. To understand this properly, I can bring this one here. It is okay. So this bottom part is for this armature here I showed before. So you can see 2 brushes are here. One is connected to one terminal and this other is connected to the other terminal. You can see the brushes here. So if I set this here, it will be like it will be like this. So the brushes are slightly touching the commutator and it spins like this. So those 2 brushes actually can touch 4 commutator plates when the armature is not moving. So when we will supply voltage to the terminals, and current will pass through the coils, through the commutator plates and the brushes. This armature will create magnetic flux, and by the reaction of field circuit and armature coil creating magnetic flux, this armature will start moving so as the middle shaft. You can see this bottom part here. This one is for the little armature here, but this one doesn't have even any brush. The contact terminals are actually working kind of brush. So now I want to let you guys know about conductors, coils and turns, and I will tell you about parallel paths later. So you can see this is a single turn coil. It has two ends. One is in my left hand and one is in my right hand. So it's a loop or a turn, whatever you can say. It's a single turn coil. You can see if I cut this in here, it will make two conductors. So one single turn coil has two conductors like these two. You can see. So a conductor is a cable or a part of a cable, and cable and coils are actually the same but they look different. And you can see here it's a multi-turn single coil, and when you will connect multiple multi-turn single coil in series, it will turn into a winding. And I showed you before how you can do the winding in the armature. And the parallel paths actually depends on the type of winding you use and the number of poles in the armature. And lastly, I want to tell you that when I put this armature back in the case, you can see in the front here it's a mechanical system where the shaft can rest and move freely like this. But with high quality motors, they will use high quality bearings here. This mechanical system will be implemented in the bottom part also, like here. So bearings are recommended for high quality high RPM motors. I think if I show you a clip of my review video about brushless DC motors, then I think it will be clear about brushless motors also. So let's take a look at the clip here. It's a BLDC motor, means brushless DC motor. Here the outer shell spins, which is called motor bell, that is connected to the internal and external titanium alloy shaft. Here the winding is in the stator, which cannot move, and there is no brush. Here motor bell is holding those magnet pieces, and it has top and bottom high RPM capable Japanese NSK bearings. This is gonna sound crazy, but this 30 grams motor is well over 1 horsepower. It is close to 1000 watts, and it can draw 50 amps at 16 to 20 volts range, so it is crazy powerful. I hope this video will help you to understand the internal parts of a DC motor. This video is especially dedicated to my friends. Some of you who didn't look inside a motor, I will suggest you to see those parts if it is possible, but you will get much better idea after watching this video. If you think somehow my video helped you, please hit the like and subscribe in my channel. If you have any question, feel free to let me know, and please share with other friends. Thanks for watching. Take care. Bye.